Welcome back to the Gruber Power Hour, a part of Gruber Power Services. I'm Pete Gruber,
And I'm Claude Dixon.
and we are here to entertain you and keep you intrigued. And again, ask any questions that you would like. We also ask that you tell us where you're from. Our viewers typically like to see the wide range that we're able to broadcast these podcasts. We get people from all over the world. And again, the focus of this podcast is to talk about critical power, uninterruptible power systems, data center protection, and our sister division, Gruber Power Services, which is actively involved in maintaining this type of equipment and providing both sales and service in data centers. So the image behind us, by the way, we like to post something up to keep the background interesting. Since today's theme incorporates clean power and some things that you can do to make sure that you're cleaning up the power in your building to protect the equipment, we decided to let artificial intelligence render an image for us. And,
oh boy.
The prompt on this one was an electrical utility room with lots of blinking lights. And what ended up happening was I kept getting these futuristic space-age data centers that were darkly lit without anything interesting. So then it finally occurred to me, let me go into the last century. And I said, give me an electrical utility room from 1960 to 1980. And sure enough, now it became interesting. But then it became even more interesting when I said, give me the same thing, an electrical utility room from 1920, 1930. And this is what it rendered. It looks pretty dirty and cluttered. And since we're going to talk about dirty power, we thought this might be fitting.
That's right. That's right.
Well, Claude.
Okay, Jesse, can you put an AI image up for me? The image that's titled AI.
Okay, yeah, one sec. Well, I think this is it.
Yes, this is it. This is a classic photo. I took this yesterday of Pete coming out of the office. And if you look real closely, he's carrying 4 objects. He's got a briefcase, and if you can zoom in on that briefcase, it is a classical briefcase. He's got a thermos bottle, and this is after work, by the way. Okay,
On my way home.
On his way home.
Right.
He's got a thermos bottle, and he's got an igloo cooler. Okay, underneath his arm there. But this other object that's weighing him down, Pete, what the hell is that thing?
Well, there's a juxtaposition of technologies there. The car that you're seeing is a Tesla Roadster electric vehicle, state-of-the-art transportation in 2008 when that came out. And what I'm carrying in my right hand is a 1970s Hewlett-Packard oscilloscope.
Let me, before you go on, Jesse, can you change that image to the poop image? P-O-O-P, the poop image.
Now, we haven't rehearsed this, so this is all new to me, too.
I don't see that.
I see it. Yep, there it is.
See it in there? Okay, hold on. They're not organized for some reason. There we go.
There you go, Pete. There's what you're carrying right there.
It is indeed. You want me to talk about that?
Yeah, talk about that.
All right. So this is an oscilloscope. It looks like a single channel, and from the 1970s, a Hewlett-Packard scope. And back then, this was a very important tool if you were involved in repairing electronics. As I was telling the guys yesterday, as a field engineer repairing computer mainframes in 1970 and the early 80s, people like us carried oscilloscopes with us and a tool bag and soldering equipment. And when you went out on site into these large computer rooms, this was before the age of distributed processing where you had little PCs at every workstation, people at their workstations had dumb terminals. And by dumb, I mean it was a CRT basically with a keyboard, and then it was connected to a mainframe computer. So when we went out to repair these mainframes, oftentimes we would chip chase right down to component level because it was possible. We didn't have LSI chips that needed to be changed, or surface mount type resistors, capacitors, components. These TTL chips, the 7400 series, for example, typically had 14 pins, and you could safely unsolder those on a board, especially if they were driver chips, which is typically what failed. So we would take the scope into the computer room with us. We would open up these large cabinets. We would pull out the offending board based on the diagnostics, and then put it on a bench somewhere or a table with our soldering equipment and change that chip to get that computer running again.
It's amazing. I wanted you to talk about that image for a bit because, what we're using right now in our depot is a device that is basically the size of my cell phone. And it does what Pete's talking about and even more. In fact, you can put the sine waves, the traces, the curves on a flash drive. And if you want to watch it in a movie theater on a big screen, you can take that flash drive there and put all this information up on a big screen. So technology has just come an incredible way in terms of, deliverance, capability, and of course, size.
Mm-hmm. And everything I just described, you cannot do anymore. You could not repair down or chip chase the component level at a customer site.
Right.
So it's now module swapping and board swapping. And then when they come back here, we fix the boards.
That's right. Okay. Jesse, I'd like for you to work with me on this because there's a few images that I'm going to ask you for.
Okay.
I want to start off with low down and dirty. We're going to be talking about dirty power first off. So the image that you're going to see is typical of a sine wave that is having dirty power problems. So let's get that image up there. Okay. And I know people watching, some of you are technical, some of you are not. So I'm going to get creative here and show you another image of how my mind works in terms of dirty power. This is what you see right here, this sine wave. The fuzziness that you see is distortion in the power line. What you want to see is a smooth sine wave. Okay, that's typically what you would see if the power is clean. In this particular example, the power is dirty. Okay, let's go ahead and put in the Choya image.
Alright,
Okay, you're looking at a Choya right here, a cactus. This to me is dirty power. I don't know if any of you have ever interacted with a Choya on the trail, but they're absolutely devastating to touch. The whole arm will come off and just cause all kinds of problems. So when I think of things in my mind and I look back at that fuzzy sine wave I showed you, I think of a Choya, absolute dirty power. Okay. Let's go ahead and go to the agave real quick. And what we're transitioning to here is a power spike. When I think of a power spike, and basically it's a dramatic impulse, like a lightning strike. It could be a mile away and still affect your operation and basically shut you down if you don't have proper protection. Okay, so this to me is a spike. I actually had an encounter with one of these on a trail. It actually, the end of it actually went in my knee, and I was dealing with this for like 2 months, Pete.
Oh, really?
2 months. And when you think of the synonym with your UPS equipment, a power spike does the exact same thing to, your UPS equipment. Your data, it corrupts it, and you spend the next, how long? It could be weeks recovering. And it took me a couple months to recover from that spike. So when I think of a power spike, I think of an agave. Just to let you know, there's 5 other areas that we're going to talk about that are classified as dirty power. So the first one, I'll reiterate again, is a power spike. Second area is a power surge. Power surge. So put up the wave image. A power surge occurs when high power equipment is turned off. And believe it or not, 80% of the problems in a mission critical environment that cause a surge, 80% are from human beings that are inside the building, either turning off or turning on equipment. And it's called a power surge because it gradually creeps up. It's not something like a spike, a lightning strike that happens like immediately. It's something that develops and then comes through the power line. Pete, have you had any instances like a digital where you had to go address?
Oh, sure.
Yeah.
We used to have a Brownout 606 power line analyzer, and what this device was able to do was record the sine wave voltages and then look for anomalies. And it actually printed out on thermal paper. Um, Now, a transient is a deviation from the sine wave,
Right.
either up or down, and it's a very short duration burst. Static electricity, for example, could be categorized as a spike or transient, whereas sags and surges or swells, in this case, are longer term deviations from the normal nominal power.
Right. Right.
And yes, the worst one that I remember was I was working on a site, and I was installing some electrical equipment, and they had what's called wild leg power, which means that there was no Y transformer. So to establish neutral, they cut into the delta transformer and split one of those. Well, everything is fine with two phases, but one phase is the distance from the middle to the other phase, which could be 180 volts.
Right. Right.
And usually electricians are pretty good about labeling the circuit breaker panels if you have what's called wild leg power, because they have a delta transformer that's been tapped. This one wasn't labeled. So here I am swapping circuit breakers around, and suddenly somebody from the office runs out to the warehouse and said, "Hey, what are you doing? Our fax machines went down, or this went down, a whole bunch of stuff went down." It turns out that I had switched a bunch of circuits over to wild leg power, and it was exactly that. It was a swell, it was a high voltage condition, and it burned up a bunch of stuff that I had to
Right.
replace.
Right. And you know, the threshold is plus or minus 10%. So if you
Mhm.
exceed the 10% mark on either side of that line, you're basically, you're causing problems. You have dirty power.
Yeah,
Yeah.
yeah, you can cause damage in the equipment that it's
Exactly.
powering.
Yeah. So you mentioned a power sag, which basically is a brownout
Hmm.
or a dip.
Hmm.
And the way I think of a power sag is show the GC drops image. GC drops. And this occurs when high powered electrical devices are started up, like air conditioners or factory machinery. Those types of things will create a sag. Now, what you're looking at here, just to give you another way of looking at it, this is the Grand Canyon, and there's 13 trails that go directly to the Colorado River in the Grand Canyon. So if you look to the left there, you see a minus 442. That means that particular trail drops 4,400 feet into the canyon. And you can see that there's 3, 4, 5 trails that are actually 3 of them that are over a mile deep into the earth. I went ahead just to, pump myself up a little bit. Where you see complete over there, those are the ones that I've actually done in the Grand Canyon. So if you look at the 3 that are the lowest, that is basically a sag to me. The average is 4,774 feet. That's the average. That's what the red line represents. So you can clearly see that those 3 trails are very, very deep, and they're anomalies when you look at, just the population, the general population.
Hmm.
So there you go. That's power sags. Transitioning to another source of power, Pete mentioned this too, is transients. And that's a brief change in a given parameter associated with input voltage or output loading. And there's a couple images I want to show you here. You guys are probably going to flip out when you see one of them. But let's put in maple first. Maple.
Okay.
Yeah. And by the way, all of the images that I'm showing you are not AI generated. These were actually photographs that I took with my own camera. So I feel pretty proud of these. This image right here is a stunning image. This is North Cascades National Park. Okay, the Maple Pass Trail. And when I think of a transient in a power line, this image came to mind. You can see the pathway, you can see the sun, which is the power, but the sun is distorted due to the mist.
Yeah.
Okay, so that mist is a transient that you want to clear out of your power line. Okay, and there's ways that you can get that done. There's equipment, a power conditioner, a surge suppressor, those types of things that can clear that image up and make it just totally stunning.
Hmm.
Another way I see transients is the alien slide. Go ahead and put that image up.
There we go.
You find that one, Jesse? Okay. These are definitely transients, okay? Transients. I don't know if any of you heard about the story that occurred last week. Did you hear about that story in Nevada? Supposedly a
Oh, the aliens that, yeah,
yeah,
yeah. I
crashed.
heard. I didn't watch
Yeah,
it.
crashed into someone's backyard, and some 8-foot green man with the person said with bright eyes,
Right.
stood up, was 8 feet tall. The person said that they froze, dropped whatever was in their hand, and
Uh-huh.
reported it. But aliens are transients. Anything that you got foreign coming in from outer space, coming into our atmosphere, that type of thing, that's a transient. So I mean, it's just a funny picture. Don't pay attention to the short alien on the right with the diapers. I don't know what that is all about. But
Yeah.
anyway, so you got the Maple Pass image, and you got this image here as a transient.
Very cool.
Yeah.
We have a question coming in. Can we take
Sure,
just a breather
sure.
here? It's from YouTube. Alvin Thomas. Welcome, Alvin. He says, "Hi, Pete and Claude. This is Alvin from Phoenix. Do you have service agreements? If so, what are the different levels?"
Yeah. Well, first of all, I actually know this individual.
You do?
Yes. Yes. Alvin Thomas, we go way back. We go back to high school, actually. Hello, Alvin. Thank you for chiming in. And to answer your question, yes, we do have service agreements. We have 3 different levels. We have a platinum service agreement, gold, and what we call silver. And the platinum is the one that provides the most in terms of response time, part coverage, actually sending a technician out to your site to, do a health check on your UPS. So yes, we have 3 different levels. Of course, the cost is different for all 3, but yeah, we provide that service.
And the service agreement business, we've been doing that since 1985. We're an insurance company fundamentally. Someone is betting that it's going to go down, and someone is also betting that it's not going to go down. It depends on which one of us or the customer. But it's cheap insurance because a major UPS repair gets very expensive. And along with service agreements, you also get scheduled preventive maintenance as a part of that package. And like Claude pointed out, there are varying levels. We have the standard 8 to 5 window, and then we have 24/7. There's even extensions to that for things like battery coverage.
That's correct. And we also service all over the country.
Mhm.
We're a nationwide provider, so just want to point that out as well.
And our service delivery, by the way, is a combination of our employees all over the U.S. and subcontractors that we have had decade-long relationships with that have grown up with us, basically, and are really very much tied into our culture and our vision of excellence for the customers.
Right. Okay. I'm just jumping back into dirty power real quick. Now, this last one that I want to mention here is probably the worst. It is the worst. It's called a blackout. And that's when you have zero voltage. You have a zero voltage condition, and it's known as a power outage or a failure. And there's some statistics here that are amazing to me, especially when you think of what states this occurs in. From 2008 to 2017, there were 1,426 blackouts in the state of California alone.
Wow.
Yes, significantly more than any other state. I'm talking by hundreds and hundreds.
Mhm.
The next state was Texas with 846. And after that, it falls down to just in the teens as far as blackouts occurring, But I do have a couple of images here I want to show you regarding a blackout. So, Jesse, put the first one there. It's just called Blackout. Okay, this is a blackout right here, but it's not as pretty as this one when it actually occurs in your facility. Okay, because this is using natural light. But just think about being in the dark. The lights black out. You're doing a tour in a cave and the lights go out. This has actually happened before, and you can't see anything. So this is just ruthless and devastating when it occurs, and it does occur. There are states where this occurs every single year,
Mhm.
believe it or not. And when that happens, 10%. They say 10% of the companies that this happens to, 10% don't recover. They never come back online. Okay. But you got to think about the size. It might be a small company. Just statistically, though, 10% of those companies never come back online. They stop doing business after about 18 months because of the data corruption and
Oh,
what they
really?
lost in the process. So, Jesse, blackout number one.
1 second.
Just another example of what this looks like. This is the Sonoran Desert down there in Tucson, Saguaro National Park, sunrise. And again, a blackout isn't this pretty. Okay, it's completely black, but I just wanted to use this image. So Pete, power quality. How do we first assess just power quality, the meter that we use, that type of thing?
Well, the fix for all of the things that Claude described is power conditioning. And that used to be in the last century, before UPSs became reasonably priced, were transformer-based power conditioners. And things like transients were resolved with an isolation transformer, where high or short duration bursts were actually filtered through that transformer with a triple shield winding, for example. Then there were sags and surges, which we talked about. That's the variation in voltage from the nominal. 208 would go up to 240 or down to 190, 170 or whatever, which would affect the equipment because it was no longer able to run. So the early power conditioners actually had tap switchers, which were solid state devices connected to transformers with taps, and it would automatically sense the incoming power and then adjust taps accordingly to keep the output power constant with the input power varying. The only thing that these two levels of power protection couldn't do was give you ride through if you had a power outage, because when the power went away to the input of the transformer, it dropped to zero on the output, and that's where uninterruptible power systems came in with battery backup times or generators combined with that. So that's traditionally how power issues, power quality issues are handled with the addition of equipment or power protection equipment.
Right. And let me go just one step further, just from a proactive standpoint. Pete's talking about what you can do to protect yourself, to reduce the issues. But there is a service that we provide. It's called a power quality analysis. And Jesse, if you can put up slide 10,000, I want to show you what this meter looks like. And what this is, it's a meter that you can put on your phases, phase 1, phase 2, phase 3, over a period of time. And you can, in your operation, you can just let it run. And this meter right here will capture everything, the sine waves, the sags, the dips, whatever is coming into your power line, first to determine even if you have a power problem.
Mhm.
And you can take this data and, do proactive things with this in terms of protection, like Pete was mentioning. And again, this is a device that will record voltage dips, swells, and transients. It puts an exact timestamp on when the event occurred. So it's really, really nice to do this proactively before you do any investment as to what it is you might need. If you put in slide 10,001, I'll show you the top side of this where you plug in all three phases. And there's a clamp that goes over each phase, each wire in the hookup. I have a picture of that too that you can see. There you go, right there. You can see L1, L2, L3. There is a connector that goes in there with a clamp on the end of it. And by the way, the reason why I have this slide named 10,000 is because that's how much this meter cost.
Okay.
Very expensive meter. And if you're going to do this analysis, I really recommend that you just have a company come in and do it. Don't invest in the meter because you'll probably use it 5 years from now again. So it's not really a wise investment, for a company to have, but a service provider, absolutely. We have one of these, obviously, and we can come out and provide that service to you. And just show 10,002 real quick too. Just a picture of the clamp that you put around the cable. There you go, right there. So there's 4 of those, one for the neutral, one for phase A, one for phase B, phase B and phase C.
And that's called a clamp-on current probe. What that monitors is the inductive field around a wire and then interprets that as the amperage that's running through the wire. The times that you would want a power study done is if you're having unexplained outages with your equipment. Sometimes, of course, the problem is in the computer equipment or in the servers or wherever. But there are times when there are external factors that are causing this, and that's a great time to get a power analysis done because then we may be able to find a root cause and resolve the problem.
Right. So let's go ahead and transition to how do you get dirty power? How is dirty power prevent it from entering your system, your data room? And there's this component called a capacitor. Okay, three different types basically. You have an AC AC capacitor, which is alternating current, and then you have DC capacitor, and you have these small capacitors which are located on a PCB board. I want to show you an image of what the AC caps look like, and their purpose is they're part of the input filter, and they correct the power factor. Okay, these capacitors smooth out transients, and it's probably not going to be what you really think when you see the image, because I just used the word filter, and you're going to see basically a can. Okay, when we get the image up,
Oh, you said filter?
AC caps. So there you go. That's an alternating current capacitor, two different sizes. And depending on the kVA size of the UPS, you could have 10 in there or you could have hundreds in there, Pete.
Mm-hmm.
In an assembly, they could be in an assembly where you just pull out 12 of them at a time and then just slide in 12, or you might have to take them all out individually. We've done both. It's a very time-consuming, intrusive repair. Obviously, you have to have a maintenance window to do this type of work, but this is a filter that keeps everything that we just talked about in terms of dirty power out of your operation.
We have a question that just came in from YouTube, by the way. EV Fan, welcome. He says, Texas had massive power blackouts. Very true, as did California, actually.
Yes.
The rolling brownouts. And the question typically here comes up, are the grids beginning to be affected by all of this demand on electricity?
Real quick, Pete, can you move your mic a little to your left to get it out of your, it's blocking your face a little. There you go.
There, okay. So we have a video on YouTube talking about the grid and the impact of EVs on the grid. And for those of you interested, it's out there under Gruber Motors.
You guys tell me I think an audience might be interested. What's the difference between just a blackout and a rolling brownout, or are there different types of blackouts, I guess?
Yeah, there are. A blackout is a complete disruption in power.
Zero voltage.
Yeah. A brownout is a reduction in voltage, which would be a sag.
Correct.
And the reason utilities handle it that way, rather than shut power off completely, they sometimes will do load shifting in order to handle increased demand, extremely hot periods in California, for example. And what they'll do is decrease the power in certain neighborhoods to try to balance out the grid. Some devices can handle it. Your toaster's not going to care, your kitchen oven. But a computer that's expecting a certain threshold of voltage will be affected by brownouts. Yeah. The servers.
Okay, I'd also mentioned DC capacitors. Jeff, so go ahead and put that one in. DC caps. I just want you to see the difference between the two. Obviously, their role is different. The DC capacitor, which is direct current, that's part of the rectification system that actually charges the battery. And it's a short-term storage location of energy that goes into the critical load. So there you are. You have the DC capacitors there. And again, two different sizes depending on what the kVA size is of the UPS that they go into.
And as Claude mentioned, they are filters. And I can describe that probably with some gestures here. When you're converting alternating current, which is a sine wave is an excursion going plus through 0 down to minus. Let me do it here so you can see because I was blocking there. So plus 0 minus
can't really
back
hear you.
up to 0. Okay. That's alternating current, and it does that 60 times a second. It changes from plus to minus 60 hertz. In Europe, it's 50 hertz. When you rectify or change AC to DC, like in a power supply where you want DC voltage being fed by AC input, what they do is through rectifiers or diodes, they take the positive portion and the negative portion through a full wave bridge rectifier, invert that. So now you have two positive excursions like this, but they always go back to zero. So in order to even out that portion where it goes back to 0 volts, they use a combination of capacitors and inductors. And the way that works is a capacitor, like Claude mentioned, is a short-term DC storage device. So if you have a capacitor connected to this new sine wave, as soon as it tries to go to 0, the capacitor discharges and it fills in that gap for the next positive peak. So now you have some ripple. It's no longer going to 0, but it's still not clean enough. And now you use an inductor, which is a choke, a coil basically. And a choke and a capacitor store energy differently. The cap has the energy stored as it's charging up to plus, and then it discharges, where a choke has a magnetic field that collapses when you try to go back to 0. So between those two, you actually then end up getting a nice, clean DC positive voltage.
Mm-hmm. Mm-hmm.
So when your caps go bad, which they will, they only last 8 years, and we'll talk about that later when we get into auto notify. That's the reason that you want to proactively change your DC capacitors in your UPS, because they're no longer filtering as well as they should. And the penalty now becomes you have solid-state switching devices that are converting the DC to AC, and it makes the inverter work harder if the filtering is inadequate.
Yeah,
So you're stressing.
There's some things I'm going to go over, overuse.
Mm-hmm.
That wear the life down of your capacitors prematurely.
Mm-hmm.
Yeah. So let's keep going here. Jesse, put in the PCB image, and what that stands for is printed circuit board. I was amazed. I was actually down in our module repair area yesterday working with one of our technicians, and he had a board out. And what you're looking at here, this board is actually a power supply. And if you can see the large black caps and the little black caps, those are capacitors on this circuit board. And I think it's absolutely amazing that we have people that can dissect these, measure these, tell whether or not they're good or bad, and replace them. These particular capacitors require a soldering skill, though, and just a meticulous effort. There's a magnifying glass there that you're looking through. Put the UCE slide in. UCE. Okay, so you see the circuit board up at the top there, and you can, if you look at the top of the screen, up top, that circuit board, that's actually a MEM5 circuit board. It goes in a single phase UPS. It's called a LX. But you look at that thing's got a number of capacitors on it. It's intense. Now, getting back to the original image that we showed you, that Pete discussed in the very beginning, that oscilloscope. Go ahead and zoom out. That device right there that's plugged into that circuit board is what we use now. It replaced that oscilloscope. It's about the size of a cell phone. Pretty amazing, isn't it?
Absolutely.
You can put the data that you're collecting. By the way, the screen there shows you everything that Pete was referencing, the sine waves, the curves, the traces, and it will tell you whether or not that capacitor, that diode, that resistor is good or bad. And then the technician can go in and do his thing in terms of replacement. Okay, Pete had mentioned life, the life expectancy of a capacitor. What's inside of a capacitor is electrolyte, paper, and aluminum. And for those hikers out there, I'm not talking about the electrolyte that you go buy in a store that's in Gatorade. We're talking sulfuric acid here. It would burn a hole through you. But it's basically paper, gel, which is the electrolyte, sulfuric acid, and aluminum foil in that can. So just think about what excessive heat could do to that if it's misused. If you don't have an air conditioner, and you're running your UPS in a closet, the overuse associated with that, the excessive heat. In an ideal environment, your capacitors will last about 10 years, but the recommended replacement time frame is 5 to 8.
Mm-hmm.
Yeah, that's what we're recommending, 5 to 8.
Because you don't want to wait
Yeah.
until they fail.
Exactly. You don't want, and if you do that, if you know that the environment in your building isn't up to par, you know that those capacitors are degrading, just like your batteries do. They're essentially the same thing. So you're going to have to be proactive. If not, you'll eventually have a failure. They won't work for you. Okay. And, you want to talk about signs of failure. You can do that with your eyes. We talked about that in the last podcast, where you can just look at the capacitor bank. Now, you're in a depot. The unit is probably energized, so you want to take the proper safety precautions before you do that. But in our operation, you can walk down there, and sometimes the machine is open, and you can scan it with your eyes. And if you see leaks or things like that come out of the capacitor, you know that something's going on there. Scorched wires, those types of things. There's a lot of clues that tell you whether or not the capacitor is functioning properly or not, outside of measurements.
Mm-hmm.
Yes.
And a resistive capacitor also feels warmer than the others. So that's another telltale sign.
Oh, I got a story there.
Okay.
I was in our depot. This was probably about 4 years ago. We had just tested. It was a 9390 80 kVA unit. Went out of the depot, came back in 2 hours later. The unit was completely disconnected, but the skins were off, and the skins are basically the side panels. And, you think the unit's disconnected, so you think it's not energized, but I reached down and I touched one of those capacitors and got zapped.
Mm-hmm.
Yeah. And this is like 2 hours later. So those capacitors actually hold energy even after the UPS is de-energized.
It's a short-term battery, essentially.
Right.
And without it being discharged, it'll hold a charge for a long period of time.
Yeah, that was a wake-up call for me.
Mm-hmm.
Yeah, in many ways.
Of course, in my earlier years in the engineering lab, we used to intentionally charge up caps to 400 volts or something. And when someone went to move them, of course, they would get a shock. It wouldn't last very long because it was fairly low current, but that was amusing to somebody in their early 20s.
Yeah, have you ever seen a scenario where the capacitor actually exploded?
Oh, yes. Oh, yeah.
Yeah, inside of a machine?
Totally. We had a power electronics module in a Tesla Roadster in Europe, actually. And a PEM is a completely sealed inverter that's in the back of a car. By the way, a Tesla Roadster or an EV inverter is the same thing as an uninterruptible power system. Its function in life is identical. It converts DC to three-phase AC. Even things like lighting inverters are three-phase inverters. So anyway, this particular cap blew its top. And like you mentioned, it's going to be a combination of a paper insulating material and a foil, like aluminum foil, which is conductive. And what we were concerned about was after it blew, it laid on top of circuit boards like this.
Mm-hmm.
And when you get conductive material on a board like this, it's going to redirect signals to where it's not supposed to go. And we were expecting to find damage to the boards. Well, this customer got very lucky. It turns out that shrapnel did not actually redirect any signals, and they were able to vacuum it out, clean it up, and it continued to run after the cap change.
Yeah, see, that's interesting. Now, I've never seen that occur with my own eyes,
Mm-hmm.
but we've had to deal with a few situations where out in the field where a capacitor actually blew up, or 2 or 3 of them blew up inside of the unit,
Mm-hmm.
and it turned into a unit replacement
Oh, yeah.
because of all the collateral damage that occurred on the other circuit boards and all the other components inside
Sure.
of the UPS. You're talking thousands and thousands and thousands of dollars for that repair, that replacement. So that's even more so, hey, being proactive,
Mm-hmm.
that kind of thing, changing your caps out when they're due and paying attention.
Oh, absolutely, yeah. Yeah, in the world of electronics, that's a fairly common replacement. Should I talk about Auto Notify at this point?
Sure.
Okay. So we talked about our service agreements earlier. As a Gruber Power Services customer, we also have a program called Auto Notify, which is a computer tracking program where we track your hardware needs. And one of them is when your service contracts come due for renewal. We track it. We will send you an email most people remember when that occurs, but if they don't, that way, they have some early warning that they need to get with procurement and get the contract administrators involved to either go out to bid again or to, renew an agreement with the incumbent, which hopefully was us, right? So if you are one of our customers, you will be getting yearly or 3-year. We have 1, 3, and 5-year contracts. You'll be getting renewal notices from us. We also have a part of Auto Notify is an early warning when your batteries need to be replaced. Typically, with an absorbent glass mat battery string, it's about 3 years is of the length of time that these batteries will last. If you skip that and you're not tracking it, you may find out at the worst possible time that your batteries don't have the power that is needed because you have a power outage. The UPS is being called on to provide backup power, and it doesn't have enough DC reserve to keep you running. So proactive battery replacements is important, and through our Auto Notify system, we will tell you when that time is due. The final part of our Auto Notify is capacitor replacements. And again, these are 8-year timers, and most people won't remember, when the last time the caps were changed because it was 8 years ago or more in some cases. So that's another thing that we track for you. We will let you know when your caps are due to be replaced, and then you can,
Yeah. The other thing too is that's critical about that is, people turn over.
Mhm.
You don't have the same people in the organization.
Good point.
So, this notice going out is critical for you. If you're a new person, you just took over as facility manager or IT manager, and you have this notice come in, it's a notice for you,
Absolutely. So those are some of the ways that we can help you. Even if you're not on contract with us, our Auto Notify will tell you when things are due. And if you have a competing service organization, we don't mind giving you the notification. So even
Right.
if you're with a competitor, let us know what your cycles are and when things are due, and we'll give you notification for free.
And don't forget about our technical assistance line. That's big too, 24/7. That number, it's a 1-800 number. You call it, and you'll get a technician on the phone.
And our customers are so appreciative of it. If they're not customers. Now picture this: it's the middle of the night. The UPS goes down. The data center is no longer running. Some IT manager, some facility manager gets called out in the middle of the night. He goes down. He realizes that UPS isn't functioning and has no idea how to start it back up. Feel free to call us. We have 24/7 tech support. We'll walk you through that startup procedure, and it's free. We're not going to charge you for that, even if you're with a competitor.
It's true.
So in these power podcasts, we also started to give some history on the various companies that have been involved in this space. Eventually, we're going to run out of companies, so we'll have to go to the next one. But for now, we still have quite a few. Last week, we talked about the history of American Power Conversion (APC), and all of these companies. They have an interesting background story. APC was not always large. They were a very small company at one point, to the point where the engineers were actually taking circuit boards home at night to bake them in their kitchen ovens. So it's kind of fun, just going through the history of these companies. Today, we'd like to talk about Liebert. And there's some pioneers in this business, in the critical power business, that really formed and started the whole business of power protection and critical power equipment. In 1946, Ralph Liebert founded Capital Refrigeration Industries. And by 1965, the company had transitioned. Whoops, my audio went out. Oh, I'm sorry. My headset is out. Okay, my batteries have died again. All right, we're going to do without batteries. These things don't last long. I think it was only like 3 or 4 weeks since I changed them. But people can hear me, right? It's not my mic, Jesse?
There was no backup there.
Yeah, no,
Pete.
you're fine.
Okay, good. Yeah, you have no battery backup for my headphones, so there's a good argument for. So by 1965, the company transitioned to Liebert Corporation, and they became the industry's first designer and manufacture of computer room air conditioning systems, CRAC for short, CRAC. Not the kind of crack you may be thinking. So these systems were designed to maintain temperature and humidity. And the reason this was important in 1965 was, excuse me, computer mainframes were beginning to populate data centers and computer rooms. They didn't call them data centers back then. Actually, they were computer rooms and computer room managers. And there were very strict requirements at the time for mainframes. The temperature threshold was 65 to 75 degrees. And I remember going into computer rooms back then, and people typically were wearing jackets because 75, even 75 was cold. 72 was really the optimum, they felt. So some computer rooms were actually that cold.
Especially in Arizona.
Especially in Arizona, yes. And in order to get that kind of temperature, you needed dedicated air conditioning. You could no longer use building air, because if you were trying to redirect building air into a computer room, the rest of the population in the building would be upset because at 72 degrees, that was pretty cold for them. So the need for dedicated air handlers became a big thing, and that's where Liebert stepped in and began to make the first computer room AC units. Now, they were designed to maintain not only temperature, 65 to 75, but also humidity. And it wasn't because of people comfort. The reason that they felt that in data centers, computer rooms at the time, you needed humidity control was for static electricity. You know, people were physically inside these large computer rooms. You had data processing operators. They had large tape drives that needed to be loaded and unloaded. You had washing machine disk drives that needed large platters pulled in and out of them to switch the data. So, and then you had tape libraries that were typically in the data center as well. Large rooms that were filled with hanging tapes. This is how you backed up your data. So these people in the computer rooms, typically walking across the floor, would pick up static and eventually discharge into these devices. So they felt that a 40% humidity level negated any kind of static problems. Sometimes they even went a step further. They would have conductive tile on the floor to mitigate static problems. So here we have Liebert now, who is making computer room AC units that are able to do two things: provide cooling and provide humidity control. The way that they would remove humidity, by the way, if you're in a very humid climate and you cool the air, the humidity level tends to rise. There's a reciprocal action there. They would have reheat options inside the CRAC units that would preheat the air before it hits the condenser and then condensate, which would then remove moisture. So there was very strict temperature and humidity control. So by 1965, Liebert was one of the companies that was offering this kind of equipment, and eventually a bunch of other companies came along. We had Data Air, for example. Eventually, APC got into the computer room AC business, same type of equipment, making CRAC units. And there were other companies that are long gone. EdPack, I think, was one of them. Data Air was another one that eventually went away. By 1977, now, Liebert launched a partner company called Conditioned Power Corporation. And the reason they did this was people began to recognize that if you're making computer room air handling equipment or CRAC units in a computer room, there was a second level of product that was needed in those rooms, which was power conditioning. So it made sense to combine those two. And again, Liebert was one of the first ones that actually created a clean power product. And it was designed, or they started manufacturing both power distribution, conditioning, and monitoring systems for the data processing industry in 1975. I just mentioned power distribution. So you now had computer room AC units that provided temperature and humidity control. You had power conditioning equipment and power distribution equipment, which was also important because instead of running conduit underneath an access floor to every one of your points where you needed power, a power distribution unit essentially was being fed by a circuit breaker panel, and now you were able to run blue flex cables, which is what they called them back then, underneath the access floor, which were flexible. So you could rearrange equipment in the room and take the power with it. These power distribution units oftentimes provided both power conditioning, cap switchers, isolation, no ride-through yet, and distributed power for the to be able to drop power to where the equipment was. By 1981, Liebert changed the name, or Conditioned Power Corporation became a division of Liebert Corporation, and Liebert went through an initial public offering. They became publicly traded at that time. By the way, one interesting side note, Liebert was always a highly competitive company, and more so than the other guys. You know, APC was, each one had a culture. APC were typically bright young men that, were running the company. Whereas Excite, on the other hand, they were good old boys from Raleigh, North Carolina, and they were typically geriatric level people, right? Liebert, on the other hand, was in Columbus, Ohio, and the owner, I guess his sons went to Ohio State, and they were football players. And next thing you know, they began to hire ex-football players infiltrating Liebert Corporation. And of course, as you probably can attest, because Claude also was a football player, they're highly competitive.
Yes.
In the industry, they were highly successful because of that. So there was a culture evolving there too. Well, by 1987, Liebert Corporation was acquired by Emerson Electric, and we were already in business by that time. The traditional way that Liebert went to market was through manufacturers' reps. And I'll describe that briefly here. In fact, I've got a whole discussion on that for a later podcast. The function of a manufacturer's rep, in its simplest form, is an independent company in a territory that represents a number of synergistic manufacturers. For example, if they're in the auto world, they would have a line of tires, a line of chemicals, a line of rubber hoses. And when they went out to an auto shop, they would be able to bring a dozen or so different products that were synergistic and educate that shop owner on the various types of products that they represent. The same was true with Liebert. They worked through manufacturers' representatives. And oftentimes these reps would have other non-competing lines that were synergistic. It turned out that the Liebert product line was so successful that very few manufacturers' reps continued to carry other lines because the amount of business that they got from Liebert was so substantial that they didn't need to carry other product lines. And Liebert reps during the day, and we would love to have been one, but we weren't big enough, were highly successful because they got so many leads from the manufacturer. The way it worked was, these types of companies did not have sales organizations. They did not have call centers. They relied on their network of manufacturers reps, probably one in each state typically, to represent them. And that was their sales organization. And as leads came in from their either trade show advertising, magazine advertising, which was the way that you advertised in the 70s, 80s, and 90s, these leads would be fed to the manufacturer's reps who would go out and close the business, and they got a commission on any type of business that was sold in their territory. So by 1987, Liebert was acquired by Emerson Electric, which was another big powerhouse back then, doing power conditioning.
Real quick, so when did the UPS come in?
Close.
Okay.
Yeah, we're almost there. In fact, in 1987, there were already some UPSs, but they were extraordinarily expensive. They were usually smaller, like 75 kVA was a big UPS. And most people still preferred or deferred to power conditioning, foregoing the ability to have ride-through. So 1987, Emerson, they became a wholly owned subsidiary. By 2000, at that point, Emerson consolidated to form a new division, Emerson Network Power Platform Group, and went through some name changes there as well. So anyway, to get back to your question, what changed things for UPSs becoming less expensive was technology improved. The old way of converting DC to AC was to use SCRs, and then lots of filtering, lots of capacitors, lots of transformers, all of which added to cost. I mean, you guys scrap old UPSs.
Well, we still service them.
We still,
You know,
yes.
that's like when I was getting to what date, you know, because I've
Yeah.
seen like the AP 300 series.
Mm-hmm.
I mean, that goes all the way back to 1990.
Yeah.
We still have them in the field. We still repair them. They're still running.
Mm-hmm. And the old technology UPSs, there's a compelling argument to upgrade because the efficiencies of these first generation UPSs was typically in the 70% neighborhood versus a newer transformerless UPS, which would be in the mid to high 90%. Now, the reason that's important, efficiency, essentially what it means is you are putting 100% electricity into that UPS and losing 30% through heat. So you have a couple of things that are occurring there. That heat has to be dealt with your crack units, which raises your electric bill because it's trying to get rid of all that heat. And secondly, it's highly inefficient. So you're using more electricity every year than you need to because you're paying for that 30% in lost energy. So we used to, when we were selling new UPSs, I'm sorry, you guys still do. When I was selling new UPSs, I would use that argument. And if you do the math, you can show the customer if you're saving $12,000 a year by switching to this new UPS, how long will it take you to pay for that new UPS?
And you know what? We're doing that.
We're still doing it,
We
yeah.
do that, but you know, I'm in disbelief with how many customers the first thing they say is, we don't have the money.
Yeah. Yeah.
You know, or our budget, you know, that's not in our budget. But
Think it's-
meanwhile, dollars are just going up in the air.
That's the problem. That's the problem with corporations is that they get budgets. And it doesn't matter whether you're bleeding in one budget because the other one looks good. It's kind of like the municipalities.
Right.
If they don't spend the money that they were allocated, they don't get it next year. So they're highly motivated to frivolously spend all that money to keep that budget at the level that it's
You know,
at.
and God forbid they have a power outage or the part's not available anymore.
Which happens,
Yes.
And then companies like us have to oftentimes go in and do component level repair or
Right.
bring modules back and repair them. So by 2016, Emerson Network Power Now, no longer called Liebert, was acquired by Platinum Equity and renamed Vertiv, V-E-R-T-I-V. And the company continues to operate under that name currently and is still providing those three main components, crack units, power conditioning, and UPSs and battery backup. Well, this is probably a good breaking point then. We will have, we do these every Friday, by the way, and Friday morning at 10 a.m. Pacific Standard Time. Participation will eventually grow as we get more viewers and more subscribers. For those of you that enjoyed the podcast, please subscribe to our YouTube channel. There are other platforms that we're not able to be on yet because we haven't reached certain size or subscriber thresholds. We're doing this out of the kindness of our hearts. We feel that we're giving something back to the community by providing information, useful information like this. And we enjoy having you join us each time.
And just to add, you know, this is our third one. So, you know, I personally want to thank you guys. I think we have, 64 subscribers
64
right now?
subscribers on YouTube now, yeah.
Yeah, we started at 0. And that was, 3 weeks ago?
It was.
So we appreciate you.
And, you know, those of you that are chiming in, if you have expertise, if you have opinions, if you have advice, please join us. This is a community. And as our other podcasts, eventually we find that there's strong participation, and we like hearing from you. So again, thank you for joining us today. We'll see you next Friday at 10 a.m. Pacific Standard Time, and we really appreciate you being with us today.
See you next Friday.